Welcome to The Explainer. Today, we're going to talk about a research paper that basically tore up the AI rulebook. It showed us that to teach a machine to really understand our world, you don't need perfect, clean data. You need the entire, messy, unfiltered internet. Okay, so let's jump right in with a little magic trick. Imagine this. You show a computer this image of a panda, and then you just add the word Australia. It's a weird request, right? A panda's not from Australia. So what do you think it would find? Well, this new kind of AI finds this, a koala. Now, think about that. It didn't just search for panda or Australia. It understood the idea of a panda-like animal and connected it to the concept of Australia. Yeah, this is way beyond just matching keywords. This is about understanding concepts across both images and words. So how on earth is this possible? How did an AI learn this kind of, human-like intuition? To really get this breakthrough, we first get to look at the old way of teaching AI, which, it turns out, had a massive fundamental problem. So think of it like this. The old AI models were like students who could only study from a tiny library of perfectly edited, super expensive textbooks. I mean, sure, the information is high quality, but there's a hard limit to how much you can really learn that way. And that created this huge bottleneck. On one hand, you've got these small, clean, expensive datasets, and on the other, you have the entire internet, massive, messy, but free. That super slow, costly process of curating perfect data was seriously limiting how much our AI could learn. So the researchers behind a model called Align, they asked a pretty radical question. What if we just embraced the mess? What if we let the AI drink straight from the fire hose of the internet itself? They decided to trade that perfect quality for just an unimaginable quantity. So they scraped over 1 billion images from the web, along with their raw, completely unedited alt text. Those little descriptions people write for images. And here's what noisy actually looks like. This is a real example from their data. The text isn't a neat description of a motorcycle wheel, right? It's just messy file metadata. But, and this is the important part, even in that mess, there's a faint signal, a little hint of a connection. And when you have 1.8 times billion of these image-text pairs, all those weak signals start to add up. The random noise begins to cancel itself out, and what you're left with is a really powerful, broad understanding of the world. Okay, so how does this actually work? How do you teach an AI to connect all these messy pictures and texts? Well, the process is beautifully clever. The main idea is to create a shared map, what they call an embedding space. And in this map, the AI learns to place the concept of a dog from a picture right next to the word dog. They basically become neighbors in this giant map of meaning. The model learns all this using a technique called contrastive learning. Just think of it like a game of hot or cold. For every correct image-text pair, like this picture of a cat and the word cat, the AI is rewarded for pulling them closer together on its map. That's hot. At the same time, it takes all the other incorrect combinations, like that cat picture and the word dog, and gets penalized if they're close. That's cold. By doing this billions of times, it learns to push all the wrong pairs far, far apart, creating this incredible map where similar concepts just naturally cluster together. So the billion-dollar question, did this wild idea of using messy data actually work? Did quantity really beat quality? It didn't just work, it absolutely blew past the previous, more complex models that were trained on that meticulously cleaned data. The sheer scale of learning was just flat out more powerful. And this chart just shows you how powerful this approach is. On a standard test for matching images to text, you can see Align just outperforming the previous best model. And get this, even without any specific fine-tuning, that's what zero shot means, it was already better. Then, with just a little extra training, it set a whole new record. All this massive training also gave Align an incredible new superpower, zero-shot classification. And that's the ability to recognize things it's never been specifically taught to recognize. So here's how it works. The model was never explicitly fed a folder of pictures labeled containership. But in its training, it saw millions of images online that just happened to have the words containership in their alt text. So it learned to associate the visual patterns of this thing with that phrase. When it sees this new image, it can confidently say, hey, I've seen things that look like this, and they're always called containerships. It's recognizing the object just by having read about it. So this is more than just a better model. It really represents a fundamental shift in how we build and, honestly, how we even think about artificial intelligence. So the key takeaway is this. We've unlocked a whole new paradigm. We've proven that massive scale can just power through data noise. This makes AI development more accessible to everyone since you can use public web data, and it creates models that understand concepts in a more flexible, human-like way. That opens the door for some seriously powerful new tools. And this allows for incredible new forms of search. Because the AI has mapped images and words to the same conceptual space, you can do a kind of visual math. You can take the concept of these black shoes and literally add the concept of the word beige to it, and the model will find an image that matches the results, a beige version of the same shoe. It's amazing. And because the whole process isn't tied to any single language, the researchers trained a version on 1.8 billion image text pairs covering over 100 languages. It's learning a universal visual language, connecting images to concepts no matter what you call them.
Which leaves us with a fascinating final thought. By learning from the world as it truly is, messy, unfiltered, and completely human, what biases, stereotypes, and other tendencies is it also picking up along the way? That is a huge question we're still trying to answer.